Hello everyone. In this class we will discuss about a small topic which is an important topic in the organometallic chemistry. We call it as stereochemical control of valency. Stereochemical control of valency. How to understand this topic? We will understand by taking up a reaction. Here I am taking a CO diars taken twice. Diars is a ligand called as diarsine. Diars means it is a ligand called as diarsine. I can take phenyls here, or we can take simple methyls. Regular one is a simple methyl, so let us take the same. Each diarsine is a 4 electron donor. It is a neutral ligand. Diarsine is a neutral ligand. So for the reactant or the substrate, slowly we are adding a thiocyanate. And once this thiocyanate is added, thiocyanate is getting inserted. We'll see what is the electron count of the reactant as well as the product. When I come to the reactant, it is cobalt, diars taken twice, NO plus. Cobalt is taken as 9 electrons, each diars is 4 into 2 electrons. So it is 8 electrons, and nitrosyl is found to be linear in this case, so it is taken as a 3 electron count. 9 plus 8, 17 plus 3, 20 electrons. But there are positive charges. 2 positive charges are there, so positive charges must be subtracted, and hence we have a 18 electron system. So the reactant here is a 18 electron system. Now if at all we draw the structure of this 18 electron system, cobalt, here is NO, and here is diarsine. 2 diarsine ligands. This is a distorted trigonal bipyramidal geometry, and in this case nitrosyl is found to be linear one. Since it is a linear one, it is counted as a 3 electron donor. It is a 18 electron system. So to this 18 electron system, if at all we are adding SCN minus, then this SCN minus will go and add on to cobalt. But once SCN minus is being added, 2 more electrons will be adding on to the cobalt. So if at all we look at the oxidation state of cobalt here, in this case the cobalt is present in +1 oxidation state, because NO is considered as NO plus or NO minus. In this case I am just taking it as NO plus because it is linear. The oxidation state we can check. Here I am just writing it. For cobalt, if I don't know the oxidation state, I am taking it as X. Diarsine is 0. Nitrosyl I am taking it as +1. Altogether this is equal to +2. So X is equal to +1. So nitrosyl here we are considering it as NO plus. Then once thiocyanate is added, it is adding up 2 electrons. So 18 electron system will be converting into 20 electron system, which is unstable. So the concept itself is called as stereochemical control of valency. To control the valency of 18 electron system, which is a stable electron system, whatever nitrosyl which is acting as a 3 electron donor linear, slowly when thiocyanate is adding and if it is giving the 2 electron system, nitrosyl will be slowly bending. So once it is bent, we take it as 1 electron donor only, and that will balance the electron system altogether to 18 electrons. This is what we call it as stereochemical control of valency. To control valency, there is a change within the space. So I am just writing it. Nitrosyl is now bent. This is thiocyanate. and this is the diarsine. So now if I look at the oxidation state, cobalt is found to be in +3 oxidation state. Why it is converted into +3 oxidation state? The reason is nitrosyl is now bent. Once nitrosyl is bent, we take it as NO minus. Bent nitrosyl is taken as NO minus in the oxidation state method. NCS, it is 1 minus charge and the complex is carrying 1 charge. So if I take cobalt, if I don't know the oxidation state, I am taking it as X. 2 diarsines are neutral, therefore I am just taking it as 0. 1 thiocyanate minus 1, 1 nitrosyl minus 1. Altogether this is equal to +1, so X is present in +3 oxidation state. So cobalt, which was in +1 oxidation state in the reactant, is now slowly converting into +3 oxidation state in the product. And if at all we consider Pearson's HSAB principle, hard prefers hard, soft prefers soft, we have a small convention. So according to that convention, cobalt 1 is considered to be softer, cobalt 3 is considered to be harder. In the thiocyanato, nitrogen is considered to be relatively harder and sulfur is considered to be relatively softer. So cobalt 1 is converting into cobalt 3. And since cobalt 3 is harder, thiocyanato will add as NCS but not as SCN. So sulfur will not bind to cobalt, nitrogen will be binding to cobalt. And one important point that we have seen is nitrosyl, which was linear, is slowly converting into a bent nitrosyl. So this come under stereochemical control of valency, where a linear nitrosyl in the reactant is converting into a bent nitrosyl so that it can maintain the valency, and sterically in this space there is a change in the chemistry. So we consider it as stereochemical control of valency. Thank you.